I was having a conversation with my aunt a couple weeks ago, who telecommutes, works from home, works for a very large aircraft company, and she was having some computer issues. And I was kind of, I can't just fix something. I always have to explain how it works. And I said, okay, so you've got your computer here, and it's talking. You want to go to that website, right? So you're going to have to access it somehow. And she turns and looks at me. She goes, oh, you mean like get to its IP address? And I said, what do you know about IP addresses? And we kind of laughed and blew it off. But my aunt is the least technical person that I would, the least technical person I would ever expect to wing out a term like IP address to me. But that's how common it's become. IP addressing rules the world. It rules how everything communicates on the internet and rules the realm of our Cisco networks. So of course it's going to be a massive topic of this series. So let's get started in it. This is going to be basic IP addressing, where we understand what the IP address is, kind of your digital home. You get to know your neighborhood, what IP addresses are around you, who you can talk to without intervention, how to find your friends on the network using a protocol called ARP, and then I would say just a massive concept that I want to plant in your mind of how do you move around the network? How do you combine layer 2 and layer 3 addresses together to communicate? I like to think of IP addressing as your digital home because it works that way in the real world. You have a house, you have an address for your house of 55 West East Street that you tell people, hey, if you want to visit my house, come to 55 West East Street. And they go, okay, great, I'll see you there at 5 o'clock. And that's how they reach you. Well, every single device that is connected to a network also has an address known as an IP address. That's how it communicates, and that's how people know how to reach it. So an IP address is 4 octets, so we'll just generate one here, 10.5.9.52. Each one of these octets, each one of these is an octet, has a value from 0 to 255. Now, there are some specific rules. Like, I can't just come in there and say, I want all zeros as my IP address, or all 255s. And there's even rules beyond that. But we'll unfold those as we go. For now, let's just know that those are all possibilities. I could have an IP address 10.5.255.9, and that works A-OK. I mean, these are all just potentials that I could assign to my computer. The rule is that every computer in the network is going to need its own IP address. You don't share an address with your neighbor, and neither do these devices. It has to be unique. Now, these IP addresses are combined with a subnet mask always, and usually, I'd say almost always, a default gateway. In a nutshell, the IP address defines your house or your location. So this is how people reach me on the network, and also the source that I come from when I try to talk to them. It's how they know to get back to me when I'm trying to communicate to them. The subnet mask defines your neighborhood. Okay, wait a second. Let's figure out what that means before we go any further. I've got the IP address right here, 172.30.100.30. I combine that with the subnet mask 255.255.255.0 as what I'm assigned to. Now, you as an administrator set this up. You as an administrator assign those. Now, at a base level, and trust me, it will get more advanced than this, but I'd say this is for the vast majority of the networks of the world, this is all you need to know. Wherever you see 255, line that up to the IP address and say, okay, those pieces of the address represent my neighborhood, or, in technical words, my network, my common ground that I communicate on. Wherever I see a 0 over here, that represents who I am in that neighborhood, or, technically speaking, the host of that neighborhood. Okay, so we've got these two key pieces, and before I even add in the default gateway, I want to make sure we unpack that and understand what that means. So if I am this computer 172.30.100.30, and I'm plugged into a switch, and I have another computer over there that I want to talk to, who is 172.30.100.150. Let's give them that IP address. Now, assuming I just don't want to write it, they both have that subnet mask on there. I go onto this computer right here, and I generate a ping. Now, what is a ping? That's the first time we've seen it. It actually stands for Packet Internet Groper. That was the original name of it. It actually has been changed to be a little more politically correct. But the goal of a ping is to test network connectivity. And if you're using a Windows PC, what it's actually doing is putting the entire alphabet, I mean A through Z, into a packet along with numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. It throws it all into a packet and sends it to wherever you specify. And then when the other side receives it, it sends it back. It's a way of testing that we can communicate across the network, at least by sending the alphabet to a device. And I will say ping is your number one network utility all the time. You will become that will be your friend in the network world. So with this host, let's give a practical example. I'm going to open up my command prompt. That's where you would use ping from, and type in ping 172.30.100.150. Now I'm typing it right here, but I'm pretty sure it won't work because I don't think that address exists. I'm just showing you what I would type. What happens then? This computer in its internal brain goes, okay, I'm trying to ping 172.30.100.150. Interesting, because I'm looking at my subnet mask and I realize 172.30.100.150 is in the same network as me. How do I know? Well, because he's in the same neighborhood. He has the same first 3 octets, which I line up to my subnet mask and realize he's in my neighborhood. Now that's a huge point, because what that tells him is I'm able to reach that device using a broadcast message. This is number one concept of the day right here. A broadcast message, meaning I can say, hello, neighborhood. I mean, imagine yourself walking out of your house with a megaphone and going, hello, my neighborhood. I would like to speak to Susan Newport. Just yelling out with this megaphone. Everybody comes out of their house and goes, what's that guy doing? And they're all like, well, he's looking for someone named Susan Newport. Well, that was disturbing. I'm going to go back in my house because I'm not Susan Newport. But somewhere down the street, you hear this little, oh, hello, that's me. And Susan comes running down to some, made-for-TV music, and you guys are united, right? Where did I go with that? So that's what the broadcast is there to do. Sometimes these analogies just come to me and they just turn odd halfway through. He's going to send a broadcast, actually a very specially crafted one, known as an ARP broadcast. Address Resolution Protocol. He's sending a message just like that. I'm looking for Susan example. He's sending a message to his network neighborhood saying, hello, neighborhood, I'm looking for 72.30.100.150. Could that person please stand forward? Now, all of the devices receive that message. They're all disturbed. But mind you, they have processors that can handle being disturbed. Broadcasts happen all the time in a local area network, and most of them, these devices will ignore. This is a perfect example. He's saying, hello, I'm trying to find 150. They receive it. They go, well, I'm not 150. I'm going back in my house. This person receives it and goes, oh, that's me. Let me send you, what's he trying to find? Let me send you my MAC address. Huge. ARP I call the MAC address sonar. Its goal is to, if I know what IP address I'm trying to access, which in this case is 150, its goal is to figure out what MAC address that device has. And in this case, it's easy because we're both on the same network. This guy can go, hello, 172.30.100.150, who are you? He responds back with a unicast. What is that? A direct message, meaning he's going, okay, well, I saw that broadcast come in and I saw the source MAC address that you're coming from, so I'm going to send a message straight back to you, meaning I don't want to bother Bob and Joe over here who's already had to be bothered by your initial broadcast. I'm just going to send my MAC address directly back to you, and now magic happens. Now this guy goes, I have all the pieces of the puzzle that I need to send my alphabet, A, B, C, D, this is a ping message, right? This is the payload of what I'm trying to send, to the destination IP address of 150, from a source IP address of 30, to a destination MAC address. Again, we have these two levels of addressing. We talked about this in the previous nugget. To the destination MAC address of, well, whatever this guy tells me. These MAC addresses are also a well-known format. Let me show you. Open, if I can get it open. Open a command prompt here, and I'll do let's do arp-a, which actually shows all the MAC addresses. It says, I want to know all the MAC addresses that you know about on your network. And I've got my own little network here, and this is me. I'm 172.30.130. It's like, well, of course, I know my own MAC address. I learned about that because that's me, but I've also learned about the MAC address of my router. These are all, let me give you the format of the MAC. MAC addresses are all 12 characters long, hexadecimal. That means you have the option of 0 through 9 at your disposal, as well as A through F. The way that they look can differ. Windows formats them with 00 dash 11-11, it uses that kind of format. I've seen plenty of other devices that format them like 00:55:11. Other devices yet go in there. As a matter of fact, Cisco does this a lot and says 0014-5192-. I mean, you might go, well, come on, what's the standard? They're all valid standards. It just depends how the person decided to format on it. But here's the common ground: they all have 12 characters. They all have values that will be 0 through 9 or A through F for each one of those characters. So my computer sends the broadcast message out, gets the MAC address of this device back. Once that happens, he has everything that he needs to send his little ABCD or whatever you're trying to send. You're sending an MP3 file, an email, or whatever you're trying to send over to that guy. He's got everything that he needs. The destination MAC address, the source MAC address, of course, because he knows who he is. Now that is sent in here, and our switch does the magic. Remember, that's what switches do. Talked about that in the last nugget. These are layer 2 devices. They learn MAC addresses. So as soon as he sings this or as soon as he sees this ping message comes in and says, oh, I see in here. Matter of fact, he doesn't even see the IP addresses. His functionality is limited. He doesn't even see what the message is. All this switch does is say, okay, I see the destination MAC address you're trying to go to, and I looked and I learned that guy goes out port 9 on me. So I'm going to send that right out here. He receives the alphabet. He replies back, kind of flips these around, says, here's the source, here's the destination. So that is, If I could emphasize how amazingly important that concept is, and I know some of you are going, okay, I get all that, I get that, but what's the dog? I just realized I have a dog on my slide. This is ARP. That's what ARP is. ARP is a broadcast protocol. It's like that loud dog in your neighborhood. That's the analogy I was planning to use before Sound of Music and Susan and everything else came out in my brain. There's a dog barking, saying hello, hello, who is, and tries to resolve the MAC address that way. But that's how it works. So before I move on, 2 more key facts. One, so that's what the subnet mask is. That's also, hang on, I said that backwards. That's what the IP address is. That's also what the subnet mask is. But we did everything that we did right there without the use of a default gateway. And that's why I said usually a default gateway. In rare circumstances, you might have that kind of network and that's all you want. You've got a bunch of devices plugged into a switch and you just want them to communicate. You don't need a default gateway, because I know you already have a feeling of where this is going. So what's the default gateway used for? Gets you off your network. Gets you to some other network, which in today's world, most of the time is the internet. Doesn't always have to be, but most of the time it is. So this guy, let me fill this key piece in. He is that 172.30.100.30, and I'll use that same story from the last nugget. He wants to go to the Bank of Arizona, right? So I go to a web browser and type in bankofarizona.com. The web browser, actually the PC, goes out and finds out, oh, the Bank of Arizona is the IP address 216.60.18.8. Let's write that up here. 216.60.18.8. Come on, somebody is feeling this puzzle piece fit right now. I can feel it. You're listening to me, you're like, oh, wait, are you going to say what I think you're going to say? I think so. So I'm going in here. He looks at his subnet mask, right? He goes, okay, 170. I'm in the 172 neighborhood. He looks at this guy and goes, whoa, stop the train right there. Not in my neighborhood. Now you could go the rest of this and say, I'm in 30, he's in 60, I'm in 100, he's in 18. I mean, these are as far apart as it could possibly be in the neighborhood world. But all it takes is just one of these numbers to be different, and he realizes this is not my neighborhood. So fit that piece together. He realizes I can't send an ARP message and reach that IP address. Well, why not? Because that is mission number 2 of a router. Remember, router's mission number 1 is to get you where you need to go based on IP address information. But mission number 2 is I stop broadcasts. That's really when I in the very opening nugget I said, what's the fundamental function of the router? It is to separate networks. This is how it does it. It keeps all of this broadcast traffic over here and all this broadcast traffic over here. Now, keep in mind, there's thousands and millions of routers out on the internet, all keeping their own broadcast traffic where it belongs. But it separates the broadcast traffic. So he knows if he sends an ARP message, a broadcast, it will flood this network, but it will never, ever, ever reach Bank of Arizona, which is out here somewhere in the cloud, that he wants to get to, because as soon as it reaches here, it bounces off. Boing, it gets dropped. So what he has to do, he goes, okay, I realize this is not on my network. I need to send this to my default gateway. Okay. If you're at a point where you're like, okay, hang on, I need to process, pause now. Because what I'm about to say is probably the most important thing you will hear the rest of this day. You can probably tell I'm given to drama, but I'm kind of serious. So what this guy does is he says, I'm going to ARP, but not for this IP address, because he knows that will be dropped. Instead, I'm going to send an ARP message for my default gateway. I want the MAC address for my default gateway, and this is the kind of packet I'm going to form. I'm going to send a ping, because that's just what I did, or a $50 transfer, or whatever you're going to do. Ping is the alphabet, right? A, B, C, D. I'm going to send a ping to the destination IP address of the bank. The source IP address it's going to come from is me. The destination MAC address it's going to go to is, come on, fill it in, the gateway, the router. This guy right here. The source MAC address it's going to go to, or I should say come from, is me. This is what allows him to send a ping message to the router, because the switch, remember, the switch doesn't even see the IP address. I kind of drew a line right here. No, it's right here. So the gateway is plugged into the switch. He sends the message to the switch. The switch doesn't even see the IP address he's going to. They don't have this capability. They just look at MAC addresses. So he sends it to the switch. The switch says, okay, I'm going to send it to the destination MAC address right here, which is the gateway. The gateway gets it. He's like, ooh, message for me. But then when he looks further, because these guys are layer 3 devices, network layer, he goes, oh, this isn't for me. This is for Bank of Arizona, and I just happen to know how to get you there. I'm going to send you out to the ISP as the next hop. That is, okay. Whew. Rewind those last 6 minutes, watch it again, then rewind it again, show your friends, rewind it again. Like if I could just solidify that concept in your mind, you've got networking fundamentals. Like that is such a big concept. Okay, I don't know, like this is related but not really at this point. I just kind of threw it in there. This is like, okay, so you're studying for the exam, you got to know this, but we'll just throw it in there for now. There are 3 core classes. Okay, so right, take this, put it into a bucket, right? Set it aside and say, that is my mastery of information. This is something I just need to know if I have a question that asks me that. For now, 3 core classes of IP addresses, A, B, and C, that we use in our networks today. There are more, but those are the 3 core that are in use. I know the address is a certain class. You know what? I'm not even going to go. I'm not even going to go there. when I put together that slide, you could tell I was like, oh good, oh good, oh good, and then it popped in my head. I'm like, oh yeah, you'll need to know this for the exam, and we will. I know a lot of you are exam focused, and we will get back to the classes of address. Believe me, that is important. It's just right now this is so good. I don't want to have you put that concept we just talked about in a bucket, and then almost get derailed and be like, oh yeah, I have to study for the exam. And it's like I want to just take it and run with it, which is what I'm doing right here. I want to take that concept. Let's open the bucket back up, right? And I want to put it together in a network scenario as a whole. This right here is how you explain to your friends and your spouse and your dog and everybody else who will listen to you how you get to Google. You are sitting right here on the network. You have the IP address 172.30.100.50. Notice the subnet mask, so I immediately identify that is my network because I line up those first 3 octets. And I have the default gateway right here going to my router. Now I tried to color code these just because when you're putting these things together you can't really fit it all. So the blue represents one network. So if let's put the scenario in here. I ping. Let's give the example 172.30.50.250, which is this guy over here, right? So I type that message into my computer. What happens? This computer looks at it and goes, okay, 172, I like that. That's my network. 30, ooh, I like that too. That's my network. Ooh, failure. 50, no. I'm on the 100 network. I immediately recognize as a PC that is not on my network. That, in my mind, says I cannot send an ARP message for this address and expect it to get there because I know there's a brick wall of a router that's going to receive that broadcast and drop it because it's going to say, well, broadcasts are not allowed. I'm a router. I stop broadcasts. So this computer is smart enough to say, well, I need to get to this address, but I have to use my gateway to get there. So he will send an ARP message, but it will be for this gateway right here. It'll say, I am looking for 172.30.100.1. I know some of you are looking at this. Follow the lines. That's for the next network. So I'm looking for 172.30.100.1, says the ARP message right here. He goes, oh, okay, great. Here's my MAC address. My MAC address, let me fill in the example, is 1111:1111:1111. Again, one of the formats of the MAC address. This guy goes, great. That's fantastic. I happen to be 1111:1122. That's my MAC address, just because Jeremy can write that really fast. So I'm going to create a packet. I'm going to have that ping be the data that I'm sending. It's the alphabet. Destination IP address. Now you fill in this box. What is the destination IP? 172.30.50.250. That's where I'm going. That's my end destination. That will not change. I have the source IP address of who? Me. 50. That's where I came from. 172.30.100.50. And know that I'm just writing this in here because I can't squeeze that whole address in there, but it is the full IP address in there. So then I'm also going to add in destination MAC address of 1111:1111:1111. Who is that? Gateway, default gateway, router that is able to get me out of my neighborhood. Source MAC address 1111:1111:1122. Right? So that is now a crafted packet that will work. Comes into the switch. Switch, what does it read? MAC address info. That's it. It goes, okay, I know because I'm looking at my MAC address table that the destination MAC address of this is out port 9. Again, I'll go there. So that now delivers the ping message to this router. Router gets it. He's like, ooh, mail for me. Because I see my destination MAC address. He then looks further and says, oh, that's not for me. That's going to 172.30.50.250. Looks at his routing table. Comes over here. Routing table has all the places he knows how to reach, and one of them happens to be 172.30.50.0. Oh man, it's like my hand moved without me, and it just introduced a whole lot of concepts right there. /24 is a shorthand notation for that subnet mask. And that's all I'm going to say about it right now. We'll get there. It really has to do with the binary behind it. The 0 address represents the network, meaning I am not allowed to use 172.30.50.0 and assign that to any computer on that network, because this represents the network as a whole. The only place I'm going to see that address, that .0 address, is in a routing table, because that router says this is how I know how to reach that network. That identifies the whole network to me, the 0 address. While we're on the topic, the last address can be used to send a broadcast message to everybody on that network. But that's later. That's like the classes of addresses, right? Key information you'll need to know, but not yet. So this router looks at its routing table and says, oh, I know how to get there. Ooh. And my routing table tells me that to get there, I need to send it to 10.5.1.2. Now, how did it know that? Well, that's where you got involved as a Cisco admin. We have to get paid for something, right? You went onto that router and educated it. You could either educate it statically and say, hey, router, to get to that network, go to that IP address. That's considered your next hop IP address. Or you can let the routers do the work for you and use something known as a dynamic routing protocol. But again, more on that later. For now, we'll just say the router knows. The router knows how to get there. So what does it do? Because we're talking foundations here. It will tear off, I'm busting out a red marker, tear off the original source and destination MAC address, because it doesn't need it anymore. That was valid for this network to allow these guys to talk, but now it will replace it with the source and destination, and for now I'll just say MAC address. Could be other things depending on the kind of network, but most of the time it will be. It will replace it with this MAC address and that MAC address. A new source and a new destination, which will be different from this one. Every network card in the world has its own unique MAC address. So you'll never have a duplicate of those unless you buy really cheap knockoff network cards, and at which point, buyer beware. So he replaces and says, okay, I'm going to do the ARP here. I've got a new source, a new destination. Put that on there, and that gets the packet to right here. This guy looks at his routing table. He goes, again, this never changed, this never changed. He goes, ooh, I've got a message here for 172.30.50.250, and I'm looking at my routing table. Matter of fact, I am plugged right into that network. He'll actually see a route in his routing table, 172.30.50.0. Send it out your Ethernet interface right here. You know, it'll be right in there. He's like, oh, I'm plugged into it. Great. So what I will do is I will send an ARP message to find out what the MAC address of this server really is, because I know that's where I have to go. So it resolves via an ARP message his MAC address, puts itself as the new source, and now we have the ping message that goes right here. Isn't that amazing? It's the same thing, very similar to what I was talking about in the last nugget. I just like covering this multiple times because it's a huge concept and I want it to go deep. It's got to go deep in you, because this is the core of how networks work. This is also the core of everything troubleshooting if your network is not working, is this little layer 2, layer 3 address game to help us move all around the network. An analogy, if you're an analogy kind of a visual person like I am. I think of this layer 3, layer 2 as like a GPS system, where I'm sitting here in Arizona and I want to drive my car up to Canada. We'll say 1,500 miles away. Now, I know that I need to get there, and that's what I put in my GPS system. But I have to have all these waypoints because I'm a man. I'm not a machine. I have to get gas. I have to get coffee. I have to get food along the way. But in all of these little waypoints, I never replace the end destination in my GPS system with a waypoint. If I'm like, okay, I want to stop at the Circle K here on the corner, that's waypoint number 3. But I'm never going to lose. I'm going to Canada. I'm going to 55 North Elm Street in Canada, because if I do, then I'll just stop at Circle K and get stuck there forever. And that's where I'll live my life and die, which is what would happen to a packet. So all of these are the layer 2 addresses. We have to have these to get hop by hop by hop by hop, to reach the different devices. And for every single network needs its own set of layer 2 addresses. But all along we keep this the same, because otherwise we'd lose where we originally came from and where we're finally going. Poof, all my scribbles disappear, and there's one more thing I wanted to add. I added this internet cloud here for a reason. When my device sends data and it ends up reaching this router, that's again the goal of the router, is to figure out where to send that data based on its IP address. If I'm sending it to the server, it's going to go, okay, I know how to get there. I go out this cable right here. If I'm sending to something that's not this IP address, it's likely going to have something called a default route. a default route looks like all zeros. It's kind of like a default gateway for a router, but routers don't have default gateways because they're routers. they are the default gateway that things go to. So it has what's called a default route that says, you know what, if you don't know where to send it, little router, why don't you send this off to the internet? Now, I know in the picture, and you'll see it in diagrams all the time, it looks like, okay, it's the Finding Nemo, right? It's like, go fish, find your home on the internet. But really, it's far more technical than that. There's really a router right here at your ISP. Whoever your ISP is, it says, here's the MAC address of that router. I'll send it there. And this little layer 2, layer 3 game goes all the way until it finds whatever server you're trying to reach out here on the internet. So the router is the decision point. Most of them have a default route for the internet. Now, how come? I mean, is there a way that this guy could actually know every single network in the internet? Actually, there is. It's something called BGP, which is the protocol that holds all of the routes of the internet. But 90%, if not more, of the routers just don't have the capacity for that. Your Linksys or Netgear at home, no way. Most Cisco routers that you use in small office, home office, small mid-sized networks won't have the memory capacity to hold the BGP. And when you get into that realm, it just becomes massive. So instead, what we do is say, okay, I know specifically how to get to that one. I know specifically how to get here and there and all my networks inside of my organization. But when it comes to the internet, I'm going to use that default route, which says, here's how you reach everything else. So what did we see here, and what do I want you to do with it? Well, what we saw is the IP addressing, the fundamentals of it. We saw how the devices are addressed, how they figure out what neighborhood they are based on their subnet mask, and finding their friends using ARP, and also finding their default gateway if they want to be able to get off of their network or get out of their neighborhood. But I would say the most important concept of all was that culmination of how the layer 2, layer 3 addressing works together, works with each other to help deliver the message where it needs to go. Now, what I want you to do with this is a few things. And again, some major concepts that we discussed here. I want you to go on your computer, whether it be at work or at home, and start proving it to yourself. First off, do an IP config. And by the way, if you are studying for the exam, you will need to know basic command line utilities like IP config, ping, ARP, the utilities that I've been using so far. And you can see that I have a local area connection. This is my network card. And right here I have an IPv4 address. 172.30.100.72. I want you to, find out what your IP address is. Find out what your subnet mask is, what your default gateway is. I want you to ping your default gateway. Go in there and ping it to make sure that you're getting responses. You should get replies back from your default gateway. Then do an ARP-A to find out what the MAC address of your default gateway is. You can, if you're curious, these things last for 5 minutes. If you don't use them for 5 minutes, they'll disappear out of, it's called your ARP cache. You can manually clear them doing an ARP-D, and I can say, okay, what's left? Nothing. It's all gone. So now when I ping it again, notice that I see it in there. Now here's an interesting test. I'm like, do I want to show this to you or I want to leave this to you? Try pinging an internet address. Do an ARP-D. I'll do it with you, just in case you don't have a computer nearby. Wait a sec. What are you watching me on? So ARP-D, and I see there's no ARP in Town. Now I'm going to do a ping to an internet address, 4222. It's actually a DNS server out in California. I just ping that. If I do an ARP-A, what do I expect to see there? The MAC address of 4222 or something else? Something else. Notice that I never figure out what the MAC address of that device is. How come? It's not on my network. My computer's smart enough to know, oh, you have to go to your default gateway to get there. So I know his MAC address. That's how I get there. But my computer will never, ever, ever know, and nor will I have a way of ever finding out unless I give them a phone call, what the MAC address is of that destination server I'm reaching, because it's not on my network. It's in another world. So do these kind of things. And I would say, if you're not too sure what to ping, start trying to find other addresses. Like I know there's 25. That's my storage server at my house. I can start saying, okay, now that's starting to show up in the list. You might go on the internet and grab a fun utility called, if I can type it in here, Angry IP Scanner. Just a fun little guy. Download the old version. It's actually much simpler, I think, than the new one. The old, go with the old Windows versions. Stable and widely used. Go for that, and do a scan of all the IP addresses in your house and create a network diagram. Draw it up just like I've been doing all throughout. Draw. Okay, you've got the computer over here. Here's his IP. Here's his MAC address. I've got the switch, which probably is invisible. I've got a router over here. I've got some other devices. My Nintendo Wii. I've got my Xbox. Whatever else you find on that network, diagram it out. Just to start really, you get the concept of it here. I need you to take this and start using it, applying it to things that you do every single day. I hope this has been informative for you, and I'd like to thank you for viewing.